All right, question 5 says the temperature T measured in degrees Celsius at the point XYZ is given by the function T of XYZ, which is equal to 128 times e to the minus x minus y minus 3z. Find the average temperature in the box, where B here is the set of all points where x varies from 0 to log 2, y varies from 0 to log 4, and z varies from 0 to log 2. All right, so just like we saw for double integrals, if I want to compute the average temperature, which I'll write as T bar, so recall that notation just tells us that we're measuring the average temperature. This is going to equal what? Well, what do we do for double integrals? We computed the double integral and then we divided by the area of the region we were integrating over. So for a triple integral kind of problem, right, a function for 3 variables, we're going to do 1 over the volume of our solid box here, B, and then multiply that by the triple integral of our function over this box. Okay, so what's the volume of the box? Well, that would just be the product of all of these things. And one thing to notice here is log 4 is what? It's log 2 squared, which is 2 log 2. So if I multiply log 2 by log 2 by 2 log 2, that will give me a volume of 2 times the log of 2 cubed. All right, cool. So now let's go ahead and set up our integral. And this region here is just a solid box. So I could compute this in really any order I like. I'll go ahead and do just dx, dy, dz. So the z bounds outside, 0 log 2, then the y bounds, and then the x bounds. And our function here is 128 e to the minus x minus y minus 3z, and the order here is just dx, dy, dz. And I'll go ahead and pull this 128 out. And so this will give me a 64 over log 2 cubed. And now I could go ahead and just compute the x integral and then evaluate, and then the y integral and evaluate, and so on and so forth. However, here is something to be mindful of. This integrand here, while it may not look like it at first glance, okay, I can rewrite this thing as e to the minus x times e to the minus y times e to the minus 3z. And we've seen this kind of thing now come up a lot. This is a product. In this case, we have 3 factors. The first depends only on x, the second depends only on y, and the third depends only on z. So, in other words, what I can do is break this iterated integral up into a product of single variable integrals. And that's going to simplify our calculations quite a bit. So we got 128 over 2. So again, that's just our 64 over our log 2 cubed. Then we're going to have, I'll just do the x integral first. So the integral from 0 to log 2 of e to the negative x. Then we have the integral from 0 to log 4 of e to the minus y. And then we have the integral of e to the minus 3z, and we're letting z vary from 0 to log 2. Okay, so now it's just a matter of computing each one of these single variable integrals, and then we will be done. Okay, so let's do that here. For this integral, I'll do this one off to the side. We're looking at the integral from 0 to log 2. So this would be minus e to the minus x as x goes from 0 to log 2. So I'll get minus e to the minus log 2. Then plugging 0 in, I'm going to get a minus e to the 0, which is a minus 1, but it's being subtracted, so this will give me a plus 1. And now, properties of exponents and logs. Okay, this right here, e to the minus log 2 is really 1 over e to the log 2, and e to the log 2 is just 2. So this really is just minus a half plus 1. So that's actually just equal to a half. So this is a half. Okay. And by a very similar argument, what is this going to give us? Well, it's going to look exactly like this, except I'm going to have e to the minus log 4. And that's going to give me a quarter, so I'm going to get 1 minus a quarter, so that's going to give me 3/4. And then for this integral here, well, a little bit more complicated, so I'll go ahead and do this one off to the side as well, just because of the minus 3. But basically the same thing. We would have here minus a third e to the minus 3z from 0 to log 2. And so now plugging in log 2, I'm going to leave the minus 1/3 out in front for a moment. I'm going to get e to the minus 3 log 2, and then plugging 0 in, I'm just going to get minus 1. Alright, so now what do we get here? Well, a couple ways you could do this. One is to say, take the minus 3 and put it up as an exponent, and so you get e to the log of 2 to the minus 3rd, and that would come out to be what? Well, that would just come out to be 2 to the minus 3rd, which is an 1/8. Okay, so this is going to be minus a 1/3, and this would be an 1/8 minus 1. So this is minus 7/8 times minus a 1/3, so that'd be 7/24. Okay. All right, and so that's pretty much it. I mean, of course, we can clean this up, but that I would say is definitely the hardest part. Okay, so what are we looking at now? Well, the 64 over log 2 cubed, then we're doing times a half times 3/4 times 7/24. So let's see here, 64 and 2, this would simplify to 32 and 1. And then for the 32 and the 4, that can simplify 1 and an 8. And then the 8 and the 24, I break down as a 1, and this give us a 3. So when all is said and done, it looks like we're going to get, oh, sorry, and then we also have the 3 and the 3 there. Let's not forget about that. So there we go. So now we're looking at what? 7 in the numerator, and then a log 2 cubed in the denominator, and there you have it. All right, thanks.